Good morning everyone. I am Dr. Munipravina Rela, Associate Professor in Department of ECE, Seetham's College. I have 22 years of experience. Today we are going to discuss about artificial intelligence. Artificial intelligence is a branch of computer science and it is mainly used to create intelligence missions and which will able to think like human, act like human, and it is able to make the decisions like human. So the term artificial intelligence is coined by John McCarthy in the year 1956. He has defined artificial intelligence as the science and engineering of making intelligent machines, especially intelligent computer programs. And artificial intelligence is also defined as study and design of artificial agents, and the intelligent agents here will be able to perceive the environment and it is able to take the decisions and make the actions so that it will maximize its success. Now we'll discuss types of artificial intelligence. The artificial intelligence is of three types: artificial narrow intelligence, artificial general intelligence, artificial superintelligence. Artificial narrow intelligence, here it is mainly used to focus to complete only one specific task. Whenever the agent has to perform any repetitive task, artificial narrow intelligence will be used. And this artificial narrow intelligence will make use of NLPs to perform this task. For example, if you take email spam filters, which is used to segregate the mails and identify the spam mails, that comes under artificial narrow intelligence. And recommender systems, facial recognition systems, and robotics which are used on assembly lines, that is used to pick up the parts and segregate the parts, all that comes under narrow intelligence. And the voice assistants like Siri, Alexa, that will also comes under artificial narrow intelligence. Self-driving car, it is used to perform only specific task, that is also comes under artificial narrow intelligence. Artificial general intelligence will be mimicking the human ability, like it is able to learn, understand the things and apply the knowledge to various tasks. Artificial general intelligence will also call it as strong AI or deep AI, and it is able to apply its knowledge to solve the problems. So for example, advanced robotics comes under artificial general intelligence. Then we have artificial superintelligence. It will be having the intelligence better than human, and it will surpass human capabilities, and it will behave more than human, and in sports, science, and we can see this type of intelligence only in the movies. Now we have also discussed that artificial intelligence is intelligent agent that will perform the task. So what is agent here? Agent is nothing but it will get the information from the environment through the sensors, and it will be acting on the environment through the actuators. So this figure will tell us about the agent. This is the artificial intelligent agent that will get the information about the environment through sensors, and sensors will be used to get the information about the environment, and it will be acting on the environment through actuators. So that is the artificial intelligent agent. For example, if you take human agent, we will get the information about the environment through eyes, ears and other organs. We get the information, those act as a sensors, and we have hands, legs, mouth, other body parts that will act as a actuators. And we have robotic agents that will have cameras, infrared range finders that will act as a sensors to get the information, and it will be having motors for taking the actions. Those are the actuators. And we also have software agents. So the software agents will receive keystrokes, files and network packets that as a sensory inputs, and it will take the action on the environment, and that can be done by using displaying on the screen, writing the files, sending the network packets. And for example, if you take vacuum cleaning agent here, we have two locations, location A and location B. What is information it will be receiving, that we call it as percepts, and the information it is receiving is the location and the status. So here if you see that it is in the location A and the location is dirty, so this is the information it will receive. What are the different actions it can take here is, it can move left, right, and it can suck the dirt, and it will also perform no operation. So this what operations it has to take, that will be given by the agent function. So this table will give us the agent function. For example, if you have the A, the location A is the location and the status of the location is clean, then what operation it has to do? It has to go to other location to check how is the status. For example, if the location is A and the status is dirty, then it has to suck the dirt. So if it is location is B, then it is clean. Then it has to go to another location, the location A, which is on the left side. So it has to move left. Say if it is location B and if it is dirty, then it has to suck the dirt, like that. So for the input, what is the action it has to take? That will be shown in this table. This is called agent function. Then we will be writing the program for this. That program we call it as agent program. So this is the vacuum cleaning agent, and what are the inputs it will take? It will take the location and the status, and it will take the give the output as action. So just now we have seen that if the status is dirty, the location is dirty, then it has to suck the dirt. Otherwise, what it has to do, it has to check in which location it is. If it is in location A, then it has to, otherwise it means that location is clean. So it has to move to the right, it has to go to location B. So if it is in the location B, then it has to go to left, like that. We'll write a program, then it is called agent program. Now the environment we have seen, no, the agent will be interacting with the environment. Environment is actually the problems. So the rational agent, whatever we are designing, that will give us solution to solve those problems. So usually the environment will be specified by like this. We have to give what is the performance measure. Whenever we are designing any agent, we have to specify these things. We have to give what is the performance measure, environment, and what are the agent actuators and sensors. All these four things are grouped under one category, that we call it as PEAS. P is nothing but performance, E is nothing but environment, A is nothing but actuators, S is nothing but sensors. So whenever we are designing any agent, first we need to specify what is PEAS. Then only we can design the agent. For example, if you take vacuum cleaning agent, how do you check the performance? We check that how much it is cleaning the environment, cleanliness, and we'll also check the efficiency. So the efficiency is here. How do we check? How much distance it is traveling to clean any particular object, or what is the battery life, and what is the security. So these are the things that will give us the performance. The environment here, it is usually we use in the rooms, and it will be having tables. Some rooms will be having different types of floors and carpets, and there are different types of obstacles in the rooms. All that will be considered as environment. How it will move in the room? It will move in the room by using wheels, and it will be having different brushes to clean the environment, and it will be having vacuum extractor to clean the room. And what are the sensors here? Sensors are the cameras, dirt detecting sensors, and cliff sensors, bump sensors. Like that we have different sensors in the vacuum cleaning agent. Similarly, if you take autonomous taxi, and how do we check the performance? How safely it is taking the customers, how fast, and whether it is following the traffic rules, and whether it is giving comfortable trip to the customers, and it has to use less fuel, and it will maximize the traffic profit. These are the things that will measure the performance. And what is the environment? Here is the roads, other traffics, pedestrians and customers. So usually autonomous taxis will be on the roads. So the other traffic, all that will be considered as environment. The actuators here are the wheels and accelerators, brake, signal, horn. All these are the actuators. And the sensors are cameras, LiDAR, speedometer, GPS, odometer, engine sensors, keyboards. These are the sensors. So whenever we are designing any agent, first we have to specify this PEAS, then only we can design the agent. And we'll see what are the different properties of task environment or types of task environment. There are 6 types: fully observable versus partially observable, deterministic versus stochastic, episodic versus sequential, static versus dynamic, discrete versus continuous, single agent versus multi-agent. Fully observable environment will give complete information about the environment through sensors. We are using sensors. Through the sensors only we'll get the information. That information is sufficient to take the actions. Then the environment we call it as fully observable. If the environment, from the environment, if we are not able to get the complete information, we call it as partially observable environment. For example, playing chess. So we will get complete information about the board. Yes or no? That is why it is fully observable environment. And taxi driving, that is partially observable environment, because we will not know about the other traffic in the environment. That is why it is partially observable. And deterministic versus stochastic. Deterministic environment, so by taking any particular action, how the environment is changing will be known before. Then that type of environment we call it as deterministic. If you are not able to predict how the environment is changing, then it is called stochastic environment. For example, taxi driving is stochastic environment, vacuum cleaning agent is deterministic environment. And episodic versus sequential. Episodic environment will be divide the task into small parts. So whatever action it is taking in one part, that will not affect the action that is taking in the other part. Then it is called episodic. Sequential means whatever action it is taking, that will affect its future actions. That is called sequential environment. For example, chess and taxi driving is sequential type. And episodic is that part picking robot, that comes under episodic environment. Discrete versus continuous. How the environment is changing. Is it changing with respect to steps? Then it is called discrete. How it is taking the inputs, how it is taking actions, that will decide the types of whether it is discrete type or continuous type environment. So for example, taxi driving is continuous. It has to monitor the environment continuously. So that is why it comes under continuous environment. Whereas chess comes under discrete. And whenever only one agent is involving, then it is called single agent. If more than one agent is involving, then it is called multi-agent environment. So usually crossword puzzle comes under single agent environment, and playing chess will also comes under multi-agent environment. So multi-agent environment, again 2 types, that is competitive and cooperative. So whenever there is a competition like playing chess, that comes under competitive multi-agent environment, whereas taxi driving, that should not be there should not be any competition there. There should be cooperation between the agents. That is why taxi driving comes under cooperative environment. And static and dynamic. Whenever the agent is thinking about taking decisions, if the environment is changing, then it is called dynamic. If the environment is not changing, then it is called static. For example, taxi driving comes under dynamic environment, whereas crossword puzzle comes under static environment. So here we see that crossword puzzle comes under fully observable environment. This comes under deterministic, and also it is sequential type of environment, and the environment is not changing whenever agent is taking decisions. That is why it is static environment. Then it is environment is changing in steps. That is why it is discrete, and only one agent is involved here. That is why it is single agent environment. Whereas chess with clock, then it is also fully observable environment. It is strategic environment, and it is sequential environment, and since the time is involved, that is why it is semi-dynamic environment. And chess with clock comes under discrete type of environment, and there is more than one agent is involved. That is why it is multi-agent environment. Taxi driving comes under partially observable environment, and it is stochastic because we cannot predict how the environment is changing after taking some action. And it is also comes under sequential type of environment, and it is dynamic environment because environment is changing whenever the agent is deciding which action to be taken. And it has to monitor the environment continuously. That is why it is continuous type of environment. More than one agent is involved. That is why it is multi-agent environment. Medical diagnosis comes under partially observable environment, and it is also static environment, stochastic environment, and it is a sequential environment. Whatever action it is taking, that will affect the actions that it is taking in the future. And it is a dynamic environment, continuous environment, and it is a single agent environment. Only one agent is involved. Thank you.